Good morning. Today I'm going to tell you something about the machine learning algorithm naive Bayes. Naive Bayes is about conditional probabilities. And we're talking about the likelihood. That's something we are interested in. And for this occasion I use the Gaussian naive Bayes machine learning algorithm. And Gaussian stands for normal probability. I mean a normal density function. I used again the iris dataset. The iris dataset is a dataset with three flowers: the setosa, the virginica, and another one. I used the setosa and virginica. I picked them out for this one because then I will have a binary classification problem with two dependent variables. I mean one dependent variable with two classes. Setosa is 0 and virginica is 1. The two flowers. And every flower has some characteristics: the sepal length, the sepal width, the petal length, and the petal width. That's part of the flower with in centimeters the width and the length of the sepal and the petal. I did a 70-30% trained test split. So we have 100 observations, which means we will have 70 observations for our training dataset and 30 observations for our test dataset. Well, let's take a look at the training dataset. What is important for this algorithm is to create a normal density function. And we will need the mean and the standard deviation to calculate that, or to plot that for every variable and for every class in that variable. So I calculated the mean for every variable and for every class, so what I just said. So you can see is that the mean of the iris virginica is higher than the mean of the setosa within the sepal length. So the sepal length is larger for the virginica, so it's a greater flower. I did that, so I calculated the mean and the standard deviation for every variable within every class. The next thing, that's the only thing I need to do within the training dataset. The next thing is to calculate the likelihood, or the y-axis, the y-axis point in the normal density function. So this is a normal function for the sepal length. It's in Dutch, by the way, but don't pay attention to that. So the y-axis, so when the observation is, for example, 4.5, and then when you go upside and then to the left, the y-axis, that's the likelihood, so the probability based on an observation. So I calculated the likelihoods I calculate the likelihood for this observation that it would be an iris setosa species, given the fact that the sepal length is 4.7. I used a formula within Excel, the normal function, It's quite handy to use because the formula is quite complex for the likelihood. This is the formula to calculate the likelihood, or the to create a normal density function. The two unknown parameters are the standard deviation and the mean, which I just calculated in the training dataset. Alright, so you can see here that the likelihoods that this observation is Iacetosa is higher than the likelihood that this observation is Ias virginica. So if we only use sepal length as a feature, we will classify this observation as Iacetosa, which is correct. Alright, so I use this this formula for every variable, the normal density function. So actually that's the likelihood for the sepal length, the sepal width, the petal length, and the petal width. So after that, I calculated the combined likelihood to be 0 and to be 1. 0 is Setosa and 1 is Virginica. I just multiplied them. So sepal length 0, sepal length probability, or the likelihood 0, sepal width likelihood 0, petal length 0. So alright, so I compared the two likelihoods to each other and decided then which one to classify. If the likelihoods of, you can see it over there, if the likelihoods 1 is higher than the likelihood to be 0, then we classify as 1, so as Virginica. Otherwise, we classify as 0. As you can see, are the first 15 observations all predicted as 0, because the likelihood of being 0 is higher for every observation. That's correct for everyone, for every single observation. You can see the accuracy. If the accuracy is 1 here, then it's correct. And over here, when we change to Virginica, we are going to the algorithm classifies as 1, so as Virginica. So that's correct as well. And we achieved an accuracy of 100%. What's important to keep in mind is that we are using the normal density function, and if we plot that function in a graph, we will be able to see the classification in the graph. So I did that for sepal length. So we have two functions, one for 0 and one for 1. So one for Setosa and one for Virginica. For example, when we have 5 as an observation in our test dataset, so sepal length is 5 centimeters, then we will look at this function and at the likelihoods. We will see that the likelihoods of being Virginica is 0. Yeah, that's 5.6, 5.9, 0.018 for 4.9, something like that. We go upside, and we will see that the likelihood to be Setosa is way higher. It's 1. So as I said earlier, is that the y-axis coordinate is the same as the likelihood as we calculated over here. So I hope everything was clear about this algorithm. This is the first time that I did it in English. I hope you understand me well. If you have any questions, leave something in the comments. Bye bye.